Okay, so in number 6, the person who designed this worksheet meant for it to mean the arc length was 9, not the measure of the arc, because when I say measure, I mean degree, right? They meant for the arc length to be 9. So let's just say, there we go, the arc length is 9. Now, they want us to find the measure of the central angle. So they want to know the measure of the central angle. We know that, not degrees, I put degrees. We know that we learned a radian, because we want it in radians. A radian is simply a ratio. It's the ratio of the arc length to the radius. The radius of circle C, well, there's a few circle C's, but the radius of that circle is 5 plus 4. So the radius is 9. The arc length is 9. The radius is 9. So the measure in radians of the angle is 1. We know that if that's the same exact angle, that when we go right here, we know that the measure of that angle, it doesn't change. Even if you're looking at a different circle, the measure of that angle is constant. It stays the same because all circles are similar. So the measure of that angle is 1. And then it wants to know the measure of arc AD. So here's when we're in weird territory. Because if I had designed this worksheet, I would mean that as what's the measure of arc AD? My answer would have been 1. But now that I'm seeing this, I'm guessing the person who designed this worksheet meant for what is the arc length of AD. So just letting you know, the arc length of AD would be 4, because it would be a number that when you divide the arc length by the radius, you get 1 radian. So this worksheet had some notation issues for sure. So the measure of the arc, as in angle-wise, radians, 1 radian, and then the arc length in part C is 4. Circle number 9, problem number 9. Given circle D, find the following information. Find the length of BC. So here's arc BC. We are looking for L. We know a few different things that we could use. We know that the radian measure is L over R, but we don't know the radian measure yet, so we can't get there. We were not given the angle in radians. We were given the angle in degrees. Yes, it is. Okay, good. 1/3 of the circle. So instead, we're going to use L over C equals M in degrees, over 360. You're right. This would reduce to 1/3, but I never reduce it. I just go straight to my calculator and cross multiply. So 10 times 120 divided by 360. Math, enter, enter. So the arc length is 10/3 pi. No pi, no credit. It is curved, so it should have a pi symbol, or at least have pi in it. The radian measure of BDC. So to get the radian measure, you can convert degrees to radians if you want, but I'm going to use this proportion right here. The radian measure equals the arc length, oh, we just found that, the arc length over the radius. The radius is 5. So we'll do 10/3 divided by 5. Math, enter, enter. Look, nothing happened to the pi. It didn't cancel. It's still there. So the pi is still there.